In this example problem, we have 2 moles of a monatomic gas that's initially at 450 Kelvin, and the gas is then cooled at a constant pressure. Constant pressure tells us it's isobaric, to 300 Kelvin. We want to know what the change in internal energy of the gas is, what the work done on the gas is, and what is the heat exchanged with the environment. So I would go to my table of equations, and I would see that for an isobaric process, to calculate the change in internal energy, we want to use the number of moles times molar specific heat at constant volume times the change in temperature. So I know my number of moles from the problem. I know that the molar specific heat at constant volume for a monatomic gas is 3/2 times the ideal gas constant. And then I plug in the change in temperature. And so since they're both in Kelvin, I don't have to convert any temperatures in this case since we're subtracting. And I can calculate the change in internal energy. And because it's energy, we're going to have units of joules. I then can go back to the table and go for isobaric. Work can be calculated as P times the change in volume, or it can be calculated as number of moles times the ideal gas constant times the change in temperature. And since I have temperature, I'm going to use the second option. So I'm going to plug in the number of moles, the ideal gas constant, and then the change in temperature, which gives me the work done by the gas. And then I go back to the table, and we're going to calculate the heat by using number of moles, molar specific heat at constant pressure, and then the change in temperature. So I plug in the 2 moles, 5/2 times the ideal gas constant, because this is a monatomic gas, and then the change in temperature, which gives me the thermal energy exchange through heat. Now I can make use of the first law of thermodynamics, and I go back and check. I plug in this number, and this number, and show that one side of the equation approximately equals each other. There are going to be some slight variations based upon rounding, but they should approximately equal each other.